Now let's look at divisibility rules. These rules are guidelines to help you determine the factors of specific numbers, and for this session I'll focus on just 2 all the way through 10. Now let's start with 2, the rule for 2. The rule for 2 states that a number is divisible by 2 if the last digit ends, or if the last digit is a 0, 2, 4, 6, or 8. So this is just trying to tell us that if the number is even, then it's divisible by 2. Let's look at a few examples. 4. Let's look at another example. Let's try 128. It ends in an even number, so it's divisible by 2. We can also look at 4,300. It ends in an even number. One more example, 4144. It ends in an even number, so it's divisible by 2. Now let's look at the rule for 3. This states that the sum of all the digits must be divisible by 3. Let's start with one that I know for sure that you know. Let's say 12. What this is trying to tell us is that if I add 1 and 2, which gives me 3, 3 is divisible by 3. So therefore 12 is also divisible by 3. Let's look at 81. I add 8 and 1 together, I get 9. 9 is divisible by 3, so therefore 81 must be divisible by 3. Let's try some 3-digit numbers. 138. So we're going to add every digit. 1 plus 3 is 4. 4 plus 8 is 12. 12 is divisible by 3, so therefore 138 will also be divisible by 3. What about 4,389? So we add 4 and 3 gives us 7. We include 8 and then we include 9. 7 plus 8 is 15 plus 9, that gives us 24. 24, we can go further again. 2 plus 4 is 6. This is divisible by 3, so therefore this is divisible by 3, which also implies that this is divisible by 3. The rule for 4 states that for a number to be divisible by 4, the last 2 digits must be divisible by 4. Let's look at a few examples. So if I have 04, consider last 2 digits divisible by 4. Now let's put that in a number, 204. Because this is divisible by 4, then the whole number is divisible by 4. What about 3,124? All we need to focus on is the last 2 digits. Because these last 2 digits are divisible by 4, then the whole number is divisible by 4. 436. Another example. So when you're dealing with the rule for 4, you just have to focus on the last 2 digits. Now the rule for 5 indicates that the number must end in a 0 or a 5 for it to be divisible by 5. So let's look at some examples here. 10, 25, which we all know, 4,105, 2355, 76545. So as long as it ends with a 5 or 0, you have 5 as a factor. Now let's look at the rule for 6. The last digit must end in a 0, 2, 4, 6, or 8. You can see here that this is a rule for 2. and then the sum of the digits must be divisible by 3. This is the rule for 3. So for a number to be divisible by 6, it must pass the rule for 2 and the rule for 3. Let's look at something like a number like 18. 18 is an even number, so because it ends with an 8. But then also the sum of 1 and 8 is 9, which is divisible by 3. So 18 is a factor, or 18 has 6 as one of its factors. Now let's look at another one, 438. You can see this right here. It ends with an 8. 4 plus 3, 7 plus 8 is 15. 15 is divisible by 3. So 438 is divisible by 6. Now let's go for something else. 732 ends with a 2, so it's even. 7 plus 3, 10 plus 2, this is 12. 12 is divisible by 3, so 732 is divisible by 6. Now the rule for 7, this one is a little bit interesting. It's quite interesting. So what we're going to do first is we're going to take the last digit, multiply it by 2, subtract the value we get from the remaining digits, and the result of that mathematical calculation must be divisible by 7. Let's pick 91. So here's what the rule states. I'm going to multiply this by 2, which is going to give me 2, and then I'm going to subtract it from 9, which is going to give me 7. 7 is divisible by 7, so 91 is divisible by 7. Let's look at one more. 462. What I'm going to do is I'm going to multiply this by 2, which gives me a 4. I subtract 4 from 46, gives me 42. 42 is divisible by 7, so 462 is divisible by 7. Now let's look at 5,929. What we're going to do here is multiply 9 by 2, which gives us 18. We're going to subtract 18 from 592, which is going to give us 574. Now, we may not be sure whether this is divisible by 7, so let's apply the rule again. Multiply by 2, which gives us 8. We subtract 8 from 57, we get 49. So 49 is divisible by 7, so 574 is divisible by 7, and also 5,929 will also be divisible by 7. The rule for 8, all we need to focus on are the last 3 digits. The last 3 digits. So let's try something simple. 008. Okay, so we'll put that in a number. 1008. Because you focus on these last 3 digits, they are divisible by 8, so the whole number is divisible by 8. What about 4512? Last 3 digits divisible by 8, so the whole number is divisible by 8. 43528. We focus on the last 3 digits. Divisible by 8, so the whole number is divisible by 8. Now onto the divisibility rule for 9. This one is just similar to the rule for 3 with one exception. For 3, we add the digits together and they must be divisible by, the result must be divisible by 3. In this case, the result must be divisible by 9. Let's look at 36 as an example. 3 plus 6 is 9. 9 is divisible by 9. So this 36 as a number will also be divisible by 9. What about 405? 4 plus 0 plus 5. This is 9, divisible by 9. So this is going to be divisible by 9. 7,299, for example, we're going to add these two together. 9 plus 9 plus 9, which is 27. So 2 plus 7 is also 9. So this number here is divisible by 9. This is also divisible by 9. 43,281. Let's try this. 4 plus 3, 7 plus 2 plus 8 plus 1. This is 9 plus 9, which is 18, which is divisible by 9. So this is divisible by 9 as well. Finally, the rule for 10. This is, I would say, the easiest rule to remember. As long as it ends in a 0, it's divisible by 10. So we got 40, 100, 31,250 ends in a 0. For the 100 ends in a 0. 41,50010 ends in a 0. So because of this number here, which is 4,150,010, is going to be divisible by 10.